Hey everybody, this is Matt with mathsmath.com. Thanks for joining us here today as we check out how to solve a system of linear equations by elimination. We're going to eliminate some of the variables there and we're going to solve our system. We're on this Common Core standard of functions, and we're going to define, evaluate, and compare functions today, having to do especially with a system. Guiding question that we'll be able to ask ourselves is, how can we solve a system of linear equations by using elimination? All right, take things one by one. Kind of reminds me of dodgeball, huh? If you think about dodgeball, what do? Take the ball, you throw it at the other team, and you eliminate one by one until you're the winner. Well, that's what we're going to be doing today. And we're going to be talking about a special equation here with money. If we think about how to solve a particular problem, if we have a certain amount of money, and we want to know how many coins we have of a particular coin, type of coin, and we'll solve it like that. All right? So we'll get that here at the end. But this is the idea. If you knew how much money you had, but didn't know the amount of coins, could you figure out the system of linear equations? How would you solve it? Any idea? Well, we're going to get to the end of the lesson today, and we'll be working on that, okay? Well, when we look at a system of linear equations, in the past we've talked about graphing, making tables, using substitution, or we call algebraically, or we can stack the equations on top of each other and eliminate a variable. This method's called elimination, and it's actually really helpful and pretty quick. What the idea there is, we'll solve a system by eliminating one variable at a time using SADMAP, and then plugging it back in to find the other variable. Not very difficult. Let me show you. Let me explain now with an actual problem. So let's talk about how to eliminate a variable. Let's talk about eliminating y first. Again, we'll have x and y there, and we'll try to get rid of y. The first step that you need to do is line up the variables. Alright, let's look at this system here. You've got y equals x minus 5 and y plus 3x equals 7. Well, the variables are not lined up. Yeah, y and y are on top of each other, and x are on top of each other, and the numbers are on top of each other, but the equal sign is in the wrong spot. So what we need to do is we need to move the equal sign. And notice that you've got y plus 3x, y and x are on the same side of the equal sign. Here, y and x are on the opposite side of the equal sign. So we need to make sure that it's consistent, okay? So let's do this. Let's move this x over. Well, how do we do that? By adding, if it's a positive x, we add a negative x, and it's now y minus x equals negative 5, y plus 3x equals 7. Now, the next thing we're going to do is cancel the variables. Notice that I've stacked them. I've put one equation on top of the other, and now we can cancel or subtract the two equations. So let's do that. We've got them written here. This is our original equations. Now, if the coefficients are the same, all we have to do is change them so that they cancel each other out. Okay, so let's do that. Coefficients are the number in front of the variables. Notice that y and y, the y's are the same. Notice the coefficient in front of the x's are different. This is negative 1 and this is positive 3. They're different. If they are the same, all you got to do is flip every single sign of the bottom equation and subtract stacked going down. So this is now negative y used to positive y. This is minus 3x, and this is negative 7. Now comes the easy part. All you're doing, we've changed the sign to make the y's cancel, but we have to make sure that all the signs of all the terms must be changed. Now we just add going down. What is y minus y? Well, that's 0. What is negative x minus 3x? That's negative 4x, and negative 5 minus 7 is negative 12. We use stacked addition. Put them on top of each other, kind of go back to first grade where you stack the problems up, right? And now we solve it. We get negative 4x equals negative 12. These two cancel because y minus y is 0. Negative x, negative 3x, put those together, you get negative 4x. Negative 5, negative 7 gives you negative 12. Okay? And then use SADMAP, divide by negative 4, you get x equals 3. Now, to check your work, you're going to plug in x and to get y. So what I like to do is I like to plug in the x value to the easiest equation. And here the easiest one was originally the y equals x minus 5. Well, what are we saying x is? 3. So plug it back in, it becomes 3 minus 5, which is negative 2. Here, if we plug it in the other equation, it'll work too. Y plus 3x equals 7. 3 times 3 is 9. Bring it over, you get -2, like you did in the second one. Okay? So your answer is 3, -2. Remember, you write your answers in a coordinate plane, because it's a point on the graph where they meet. Okay? Not too bad, huh? Now let's talk about how do we eliminate x. We're going to line the variables up. Again, doing the same thing we did the first problem. Notice I'm using the same equations too, okay, so that we can check our work and we know what we're doing. We know what the answer is to guide us there. Now what we do is we cancel the variable, but we have to multiply. Notice that the signs are different. This is minus, this is plus. So that's a good sign. But this is 1, right? Imaginary 1. And this is 3. So how do I multiply this equation to get a 3 by the x? Well, all we do is multiply the whole equation by 3. We're going to multiply every single term in the top equation by 3. And let's see why we do that. This becomes 3y minus 3x equals -15. If you notice, now we have minus 3x and plus 3x. If we combine those, bam, they're gone. And all we're left with is 3y and y. And you can do that pretty easily. We add going down to cancel the x's. Remember, our job was to make it so the x's go away, that they eliminate the x's. Okay, again, we add going down. We get 3y plus y. Using stacked addition, 4y. -15 plus 7 is -8. And then we get that y equals -2, which is what we got last time too, right? So answers should be the same. So we plug in -2 to the easier equation. The easier one might be that first one, where it's y equals x minus 5. This is -2. Bring +5 over, and you get +3. X equals +3, which is what we got last time, right? Answer still 3, -2. No big deal. Right? Let's say you have 20 coins, both quarters and dimes, totaling $2.75. Let's write some equations. Now, x represents the number of quarters, y represents the number of dimes. So if I add the numbers of each of them, I'll have 20. Now, if I write it like this, where I've got 1/10 x plus 25/100ths y, why did I write 0.1 and 0.25 there? Okay, well, I did that because these are the dimes and these are the quarters. So this is the number of coins we have. This is 0.1, so 10th times x, the number of dimes we have, plus the amount here of the quarters is $2.75. If we line them all up, what do we multiply that 0.1 or 0.25 by? Well, if we multiply this by 10, everything by 10, this by 10, this by 10, this by 10, and then we subtract it, we'll get our answer, which is 15 and 5. Okay, let's solve these systems by eliminating. Remember, you want the y's to be opposite of each other, so you either make this one negative, this one positive, or make this negative, this positive, and that positive. All right? Same thing here. We've got y equals, then we've got y minus 2 equals. So we can't have that, so we've got to bring the 2 over to the other side, and then solve it going down. Well, the sum of two numbers is -25, and their difference is 15. Well, to think about this one, you just take x. You do x plus y equals -25, and you would do x minus y equals 15. Solve it, and these are your answers: -20, -5. All right. Are you able to answer this question now of how we can solve a system of linear equations with elimination? I bet you can. Not too bad, huh? Just focus on which variable you want to get rid of. Usually get rid of the easiest ones with no coefficients or numbers in front, okay? And that's it for today, as we talked about money and solving a system of linear equations by eliminating. This is Matt with mathsmath.com. Thanks for joining us. Check us out on Facebook at Solving Math Problems, and on Twitter at Maths Math, and enjoy math.